I'm going to be doing the fireproof balloon experiment. So here I already blew up one balloon. This is just filled with air. And this balloon, as you can see, is filled with water and air. So the first thing that I'm going to do is we're going to light a flame to the bottom of each balloon. And what should happen is this balloon, the orange balloon, should pop, and the green balloon shouldn't. So we'll see what kind of happens when I light the flame to it. Okay, so with that balloon, it popped clearly. Now this one, it shouldn't pop. Okay, so that didn't pop, and as you can see, there's like black underneath. So the whole question is, why does the balloon with no water break? And why does the balloon with no water break when the flame touches it? So basically, the flame heats whatever it is placed in it. So as you can see, the water was in this one. So for a balloon, the orange balloon, it popped, and this one it did not. The rubber balloon without water becomes so hot that the rubber is too weak to kind of withstand it and resist the pressure of the air of the balloon inside. But the other question is, how does the balloon with water in it resist breaking when the flame hits it? So the water inside the balloon that the flame is hitting, the water is absorbing most of the heat from the flame, which means the rubber balloon doesn't become very hot because it's warming the water inside the balloon. So because the rubber does not become hot, it doesn't weaken the balloon. Therefore, the balloon doesn't pop like the first one. So water is typically a very good absorber of heat, and it takes a lot of heat to change the temperature of water. Typically, from my research, I found that it takes 10 times as much heat to raise the temperature of 1 gram of water by 1 degree Celsius than it does to raise the temperature of 1 gram of iron by the same amount. So this is why it takes so long to bring like a tea kettle, for example, to boil. And as they say, like a watch pot never boils. So that kind of like goes into the tea kettle aspect, because the tea kettle has a lot of water, and that's why it takes much longer for the water to boil in that. On the other hand, when water cools, it releases a great deal of heat. So this kind of explains why areas near oceans or other large bodies of water do not get cold. The water doesn't get cold in the winter as areas as the same latitude further inland. So that's kind of why when you go into a body of water during the winter, it may be warmer than you think, because it typically takes a long time for that body of water to heat up in the summer. So when you go to the beach in June or July, the water, you'll probably think it's still cold. That's because we just gotten done with the winter months, and even though in June and July it's warm, the water is still cold because it takes such a long time to heat such a large amount of water, which is kind of what I explained earlier. The same thing goes for as if you're swimming in the ocean in September or October. I've never been swimming in the ocean in October, but I've heard that the water is much cooler than outside. That's because once it's already hot, it takes a long time for it to lose that heat. So I just wanted to point out that the black soot on this balloon is carbon. The carbon was deposited by the flame, and the balloon itself remained unchanged. So that's kind of why this happened. Now, if I flame to the balloon up here, it would pop. So the flame heated up the water, and the water overall is a great for soaking up heat. And that was the fireproof balloon experiment. Thank you.